But that's not yet really ideal, because what we want is we want to scroll through each hour of the day to really see what's happening during lunch, in the afternoon, and so on. For that, we need to, so we keep this, but we will create a copy of these two components, so we can switch between the average output and the hourly output. Now, what we need to do in order to select the hourly data, in order to select one item out of that data, we will use the list item component. So instead of calculating an average of the numbers we get, we select one item out of that list, and we do that for all of these. And in this case, the item we choose is the hour of the day, but for each of the faces of that mesh. So we import the list. It's the first thing we can do. And instead of feeding the average into here, we feed the item into here. So that would be this. So how do we get how can we choose the right hour within the data, the analysis period? It took me a while to really understand, but if you have it, you understand it. We need to get a component, this one. So what we want to choose is the hour of the year. The hour of the year, that's what we choose. But we want to choose it from within that week we are testing. We could also choose something completely different, but because we are feeding only that 1 week into here, we need to choose also the right data from. We cannot choose a day or an hour outside the data set. That wouldn't make any sense. So how do we get the hour of the year? So what we can do, we can get first a panel just to as a visual aid in what we're actually checking. So this would be the month, the day, and the hour. So this is the week we are testing. If we stick with that week, we can copy that copy that here, disconnect, and write the 6. Month is 7. And the hour is 1. So this is my start day, and it gives me the hour of the year. So this is the first hour of that test period, 44665. In order to choose the item now, because we don't have the whole year in that data set, we only have a week. So we need to subtract this from the day we actually want to test. So we copy this and we add a subtraction. Take this here and this here. That's the start day and the start hour. And this is the day or the hour when we want to test. So if we replace that here with slider, so now I have my typical selector for the day, month, and hour, and we know that the end date is July the 12th and 24th. 12 and 27, which is my month, and 24. That would be my end date, and that gives me the number 1167. So that gives me the ability to actually scroll through the days and the hours. Restrict myself here and keep that days only from 6 to 12, because that's the range here. So I can only choose between the day 6 and 12 because that's the week, and the rest is fine. I could also restrict my month to just one number, and then here I have my hours which I can go through. If you scroll up to the last hour of the week, then you get an output of 176. That is not to be confused with the values, because the selected hourly data or all the hours of that week are actually 168 hours. But if I put it in here, you can see that the first entry is 0 and the last one is 176. So it has 168. It has 168 values, but it's counted from 0 to 167. So just keep that in mind. And now we just only need to connect this here, and here, and also here. And let's turn this off. It's actually funny that this shouldn't be a problem yet. So this still works. It works fine. You don't need this one. And here it should also work. And it does not, because that's why I love the panel so much, because you can always see what's inside. What's inside here. Okay. So the reason is we need to flatten this. Otherwise, flatten. Also weird output. Why is that? Oh. If this is not flattened, it doesn't matter. It gave me the correct output, but let's flatten this. Yeah. So yeah, I had the wrong input here. Well, it looks pretty good. So we can now actually scroll through this. Now I have two overlapping analysis. Let's close one. Let's deactivate this. And you can see that we can scroll through each day to see what's happening. Let's go to the extreme hot week. What's going on the hottest day? Okay, so now be careful, because we need to update this here. That doesn't work anymore. So that means 3. This is 9. Sorry, this is 8. So obviously August is the hottest month in Korea. It's correct. And then we restrict ourselves from 3 to 9. These are the days. 3 to 9. The month we can choose, and the hours. And now we can scroll through the hours. And you can see the movement of the sun created by the shadow. It's pretty hot during these days. Maybe we can here's a bit better. The first day of that week. Let's go to probably the most hottest time of the day. Oh, 11 seems very hot. So we could go through here. 40 degrees. That's extremely hot. 36. 41 at 1 o'clock in the afternoon on that day. That's extreme. So what would that mean? You can only increase the shading, but that gives you a pretty good idea of the very specific time, a very specific outdoor comfort in your design area, or in your model. There's one more thing which I would like to discuss. So there's several things I want to still do to this to get a bit of a better result. One is the ground reflectivity, which can be a value from 0 to 1, and currently it's set to 0.25, which is characteristic for outdoor grass or dry bare soil. So that actually doesn't represent like urban paving material. So you could actually go into here and add a slider and see what that could be. Now it's calculating again. And you can see, so if I have a different material, then this can go up to 45. So now the only way would be to try to increase shading. Is there a way to increase shading? Do we need double shading? How much shading do we need? Just adding random for the testing purposes. Yeah, quite a problem with, I mean, more, we cannot really add more shade. It will not really lower the temperature. Yeah, it's pretty much stuck on that 30 degree. So in that case, it would be of course good to understand a bit more about the wind situation. Is there a way to have a natural wind ventilation throughout the space? That would be another study, of course, but that could actually help, and maybe you then get another output. So if, for example, this would be my wind speeds, hope it's correctly, and wind speed, for example, here it's 3.6. What if I increase that? Let's say what if I increase that by a factor times 2? That's already quite a strong wind, but let's see what's happening. Yeah, it actually went a bit down. Just to get an idea. Okay, if I even have more wind speed, so that means you need a lot of shading. But you can also think about your material, the ground material. So that means also that the more green area you have, the better. So if I go back here and put in soil or grass, then yeah, it didn't lower much. Still very hot, of course. Still very hot. But could you, for example, go even lower? Water. You need to add water surface, which draws more, which kind of absorbs some of the heat. Doesn't really happen much, but it reduces the temperature quite a lot from, let's say, 37 to 30. 30 is still much better than 37, of course. So there is kind of an improvement, definitely, with the shading. Now let's check, let's put it back to what we had. Let's say 1.5 average reflectivity. I don't know exactly about the reflectivity factor and would need to research a bit more, but let's go with what we have here. So now we could also look into how does that look like in the extreme cold week. Okay, extreme cold week. So there, the shading is actually an issue. The shading is actually an issue here because it makes the space feel even colder. So everything without shade is actually more comfortable as the space within the shade. We are at lunchtime, so we can also then, sorry. First, again, we need to check the date. So we are wrong. Means that we need to change day. Yeah, here is funny because you actually can see that the shading doesn't do much here. It's actually making it worse. But around that wall, it's somehow better, probably because so obviously there's more light coming to that space. And Anyway, I think you get what I mean. It's very, very interesting to see and to scroll through. -12. Whew. Feels very cold here. The shading is actually very bad for that. So what would be the solution for such a space? How can I provide shade in summer and no shade in winter? The answer is planting. So I could have a deciduous tree which provides shade during summer and no shade during winter. That would be one of the best solutions and probably one of the most sustainable. So if I kill all these, again, I mean, this is like extreme situations where, of course, it's very hard to do anything, but it feels like that creating a better space throughout the day. I mean, this seems like an extremely cold day, but there are other days where you might consider to go outside. Like, for example, yeah, this one wasn't so bad. But yeah, I think you get what I'm trying to tell you. So in such a case, really the best would be to have trees, deciduous trees, which lose their leaves during winter and provide more sunshine, but then in summer provide shading. So let's go back to my extreme hot week, and you can see, okay, let's update this here again. I might need to write the script for that, but I haven't yet done that. Apologize for this. So at the moment you need to do it like this, but if you have an idea, a better idea on how to input these things, please let us know. Trees are definitely the better way to shade such a space where you have very hot summers and very cold winters, very cold winters, because you don't want to end up with a shading device with a permanent shading, which then just creates an extremely cold environment. So trees is the answer, please. Now let's add some things here to make this thing a bit better. Let's disconnect the data here. We can rename this with Celsius, which is the legend title. So you can see that it updated the legend title. We can then analyze title, which is, I could call it perceived temperature. Then we can change the gradient library, the outdoor colors, custom colors. For that we need the legend parameters. This is this one. Legend parameters and the custom output colors. And we grab a slider from somewhere, and I think that was from 0 to 2023, and there's one which is the UTCI 1 and 2. 9 is the thermal thermal comfort colors. Let's use that one. No, let's use the second one. I think this is newer, number 13. So these would be the colors we could use. It's a bit annoying that this doesn't. It's placed not outside the test area, but we can always bake it. I think there's also a way to adjust the position. Legend location, yeah, we can exchange the location, but this is the legend. So if I have a point here, I can move my analysis title. I don't know now, but I mean, you can always bake it and then move your text wherever you want. And you can then turn this off. That's a way. So what I want to do now, just a last thing. So I just want to check one more thing before, when we started the series, this episode, or these episodes about outdoor comfort, we said, can Rhino actually help us to determine the best time to go on holiday, to a place on holiday. So for example, I could now go through this the typical hot week, that is July. A typical week is October. And let's see how that does. And now we need to adjust our days again. So you can see already pretty much everything here is in a reasonable temperature or perceived temperature. If I go up, there is sometimes in the bare sun where it's a bit more than you would like to have, but it's still in a reasonable range, and it goes up to 30, but everything else is pretty much quite nice, I would say. Sorry, the month cannot change. Maybe just check another day. 17th is a bit cooler, but during the day it's actually quite perfect. That tells me that most people are gonna be outside during that time, and most tourists will be there, so it's good to provide some shade, but not everywhere. And autumn might be some trees might be already not as dense. I mean, this is not a real tree model, it's just a sphere. It doesn't represent a tree, but this is just a replacement for it. Of course, there will be more light coming through and there will be less shade provided, but that could be a way to think about, you know. So actually, so this time of the year was probably the nicest time to go there, from the 6th to 13th or something like that. That would be the best time to go there, and I based on that, what I see here, it's probably true. So you might want to check for yourself, and next time when you go on holiday, you can check when is the best time to go to a certain place. Sorry, forgot something. Of course, I mean, you can then increase or can use this script on any scale of your model. Here, for example, in order to make it more simple, I'm just choosing a rectangle as my test surface. But what I would suggest is to increase the grid size for 3 meters, and we're gonna put our test surface. It's already selected, and the context, and now I don't get anything. Yeah, I already know what I did wrong. My own precaution. So this is my test surface. Yeah, so it's funny. Okay, because I defined the location of my legend here, so I actually need to push it here or somewhere else, and now you can see that we calculated that whole streetscape or that whole district. Let's it's interesting. I got quite of a shading here because of the buildings. But yeah, you can. But so if you test bigger areas, just keep in mind to increase your grid size first, just to be safe. Okay, I think that's it. Best time to go to Korea is October, second week of middle of October basically. So I would trust Rhino, but I guess the week before is also very good. With that, I will close this episode. If you have any questions, let me know what you think. Subscribe, hit the bell button. The bell button is the most important if you want to see more of my stuff. Otherwise, check out the ladybug.org page. There's a lot to see, I think, as well. Yeah, that's it. Have a good time. See you then.